There are so many awesome things around us, and all of these are made up of atoms. But have you ever wondered what makes these tiny atoms stick together in this shape? Well, that happens because of different kinds of chemical bonds between these atoms. And today we are going to talk about one of them, covalent bond. Basically, these are chemical bonds where atoms mutually share electrons to be together. Now, in the video of ionic bond, we have seen how atoms can lose electron and gain electron and get oppositely charged and attract each other, stick to each other. That makes sense, right? But how can atoms stick together by just sharing of electrons? Let's find out. So let's take a fluorine molecule for example. See, one molecule of fluorine has two atoms of fluorine, and these two atoms are sticking together. Now let's see how these atoms are sticking together. Are they losing electron and gaining electron, or something else is happening here? So for this, let's write down the atomic number of fluorine, which is 9. That means a neutral atom of fluorine will have 9 electrons going around it. And its electronic configuration will be 2, 7. That means there are 7 electrons in its outermost shell. Now let's draw the outermost electrons over here. And here we are only going to draw the outermost electrons because, in a chemical reaction, only the outermost electrons participate. Only they are lost or gained, okay? So there is no need to draw the innermost electrons. So 7 in the outermost shell. So 7 crosses. Yes, I'm representing the electrons with crosses here. Similarly over here, 7 crosses. Now see, we know that atoms, they want to become more stable like noble gases. And noble gases, most of the noble gases have 8 electrons in their outermost shell. So even these two fluorine atoms will want 8 electrons in their outermost shell. Currently they have only 7. Now, which one will lose and which one will gain? Will that even happen? Let's see. If this fluorine atom loses an electron to this one, see, this atom will have 8 electrons, but this one would have lost one. It has only 6. So this is not stable, right? Even though this is stable and happy, this is not going to be stable. So this kind of business is not going to happen between them. Nobody is going to lose or gain electron in this molecule. So how are they sticking together? Well, in this case, they are sharing electrons. Both these atoms are sharing one electron with each other, something like this. So what happens in this case is that this electron of this fluorine is not only going around this fluorine atom, but after being shared, it is going around both the fluorine atoms. Similarly, this electron of this fluorine is not only going around this fluorine atom, but now after being shared, it is going around both the fluorine atoms. So basically these two shared electrons from each of the fluorine is not only bound to one of these fluorine atoms, but now they are going around both of these fluorine atoms. Now you might be wondering, how does that help? See, if you just focus on this fluorine, then see, it has 6 electrons bound to just itself. And now these 2 electrons are also going around it. So this fluorine atom experiences 6 plus 2 electrons around itself, meaning 8 electrons around itself. And that's why it will find itself to be stable and happy. Now similarly, if you focus just on this fluorine, now it has 6 electrons bound to itself. And now these 2 shared electrons, they are also going around it. So this fluorine atom experiences 8 electrons, 6 plus 2, 8 electrons around itself. So this is stable and this will find itself to be happy. So this is how by sharing one electrons, both of these atoms can complete their octet and become stable. Now let me explain you the sharing part with one more analogy. Let's say you and I are dog lovers and both of us have 7 dogs each. But for some weird reason, we both will be extremely happy if we get to play with 8 dogs each. Now how can that happen? So for that, we both can share one dog with each other. Something like this. See, now these 2 shared dogs, they are not bound to play with just me or just you, but they will be playing with the both of us. Okay? Now in this case, if you just focus on me, then see, I have 6 dogs which will just play with me. But these 2 shared dogs are also available for me, right? So I experience that I have 8 dogs to play with. 6 plus 2, 8 dogs to play with. So I'm extremely happy. Now similarly, if we just focus on you, you have these 6 dogs just to play with you. And now these 2 dogs are shared. So that means even you can play with them. That means you will also experience 6 plus 2, 8 dogs to play with. And that's where you will be extremely happy. Okay? Now this is how, by sharing our dogs, we both get to be happy. Now see, if we want to be happy always, then we'll have to stick together and keep on sharing our dogs, right? So in this case, I can say that you and I have bonded together. Now something similar is happening even with the fluorine molecule. Here the fluorine atoms had 7 electrons and needed 1 more to be stable. To gain 1, it had to share 1 electron with each other. Okay, that's how they became stable. Now see, if they want to be stable forever, they will have to keep on sticking to each other and sharing 1 electron with each other, right? So this is how a chemical bond is formed between these 2 fluorine atoms. And now since this chemical bond is being formed because of sharing of electrons, we call this a covalent bond. See, co refers to sharing and valent refers to valence electrons. And here the valence electrons are being shared, right? That's why it's called covalent bond. Okay, one last thing. See, to represent a covalent bond simply without these crosses and circles, we can draw a dash between the 2 sharing atoms. Just like this. One single dash refers to a pair of electrons or 2 electrons being shared between these 2. So these 2 electrons can be replaced by a single dash, and this means that these 2 atoms have a covalent bond, a single covalent bond between them. Now let's look at a couple of more examples to understand this concept a little better. This time let's talk about oxygen. Oxygen has 8 electrons going around it. And if I write its electronic configuration, it will be 2, 6. That means there are 6 electrons in the outermost shell. Let me draw it and show it to you. So this is the oxygen atom, and here there are 6 crosses representing 6 electrons. Now see, its octet is not complete. It does not have 8 electrons in its outermost shell. That means it is not stable. Now how can it share electrons with another oxygen atom to have complete octet, so that both of them have complete octet? Can you pause the video over here and try to figure this out? How many electrons will be shared between these 2 oxygen atoms? Now if you have thought about it, let's see. So if you thought that they will be sharing 1 electron, let's see what happens. If both of them share 1 of their electrons, then see, this oxygen atom had 6 already, and now it will have access to 1 electron from here. That means 6 plus 1, 7. So that means the octet is still not complete. So just sharing 1 electron is not going to help. This time, they will have to share 2 of their electrons with each other. Something like this. Let's move this. Yes. So now you can see that this oxygen, it had 6 electrons, and now it has access to 2 more. That means its octet is complete. There are 8 electrons for this oxygen. Similarly, for this oxygen, there are 6 plus 2, 8 electrons. So its octet is also complete. So this time, each atom had to share 2 electrons with each other to complete each other's octet. And now both of them are stable. So here in this case, since there are 2 pairs of electrons getting shared, one this and one this, we say that there are 2 covalent bonds between 2 oxygen atoms. So if we have to write this in simple terms, we will say that between 2 oxygen atoms, there are 2 covalent bonds. There is a double covalent bond here. Whereas in case of fluorine, we saw a single covalent bond. Now let's look at one more example. So this time, let's talk about nitrogen. So nitrogen has 7 electrons in total. So its electronic configuration will be 2, 5. That means it has 5 electrons in its outermost shell. That means its octet is not yet complete. Now, can you pause the video and try to draw it by yourself and show how many electrons will be shared between 2 nitrogen atoms so that both of them have complete octet? Pause and try it by yourself first. Now, if you have tried it, let's see. So here I have 1 nitrogen atom and I'm showing 5 electrons in the outermost shell. And here I have the second nitrogen atom. So see, since 1 nitrogen atom needs 3 more electrons, it has 5 in the outermost, 5 plus 3 will be 8. So it needs 3 more electrons. Therefore, it needs to share 3 electrons with the other nitrogen. Something like this. Yes. Now if you see carefully, this nitrogen has 5 plus 3, 8 electrons. Its octet is complete. And similarly, this nitrogen's octet is complete. And this is how they will covalently exist. Now over here, if we have to count the number of covalent bonds, see, there is one pair being shared here. Let me change the color. One pair of electron, second pair of electron, and third pair of electron. So in total, 3 pairs of electrons are being shared between 2 nitrogens. So over here, we see that when 2 nitrogens share electron, there is a triple covalent bond between them. Okay? So we saw that fluorine has single covalent, oxygen has double covalent, and nitrogen has triple covalent. Now one last question. How does hydrogen share electron? And this question is unique because hydrogen has just 1 electron. And it does not follow the octet rule. It does not need to have 8 electrons in its outermost shell to be stable. But instead, it follows duet rule. Meaning, it needs to have 2 electrons in its outermost shell to become stable. Now, with this new information, can you pause the video and think about how 2 hydrogen atoms share electrons to be stable? Now, if you have tried it, let's see. So here I have one hydrogen atom and it has 1 electron, and another hydrogen atom with another electron. Now we know that hydrogen needs 2 electrons to become stable. So in this case, both of these atoms will share 1 electron with each other. Something like this. See, now this hydrogen atom has 1 of its own and then 1 being shared, meaning total 2 electrons. So this will be stable. Its duet will be complete. Similarly, this hydrogen will have 2 electrons around it. So its duet will also be complete. And this is how they will share electrons by a single covalent bond. So here we will write hydrogen has a single covalent bond with another hydrogen. And this is how H2 gas exists in nature. Now let's summarize the video. In this video, we spoke about covalent bonds, basically where atoms share electron to become stable and stick together. We saw that these bonds could be single covalent or double covalent or triple covalent bond. And the major underlying principle was that if atom needs 1 electron, then it needs to share 1 electron. If it needs 2 electrons, then it needs to share 2 electrons. If it needs 3, then it needs to share 3.